Hello everyone. In this video we will learn something more about quadratic equations. We will learn about the sum of the roots condition and product of the roots condition of a quadratic equation. And also we will see how to solve the problems using the sum of the roots and product of the roots condition. If alpha comma beta are the roots of the quadratic equation ax square plus bx plus c equals to 0, then sum of the roots is equals to minus b by a. The condition for sum of the roots is equals to minus b by a, and the condition for product of the roots is equals to c by a. So whenever we have roots as alpha comma beta and the quadratic equation is ax square plus bx plus c equals to 0, then the sum of the roots is equals to minus b by a and the product of the roots is equals to c by a. So let us see, if alpha comma beta are the roots of the quadratic equation, then the sum of the roots is equals to minus b by a and product of the roots is equals to c by a. How we get this condition? How are we getting both these conditions? Let us see by proving this. So we are given quadratic equation ax square plus bx plus c equals to 0. So in the previous video we have already seen the roots of the quadratic equation are the roots of the quadratic equation ax square plus bx plus c is equals to 0 are minus b plus or minus under root of b square minus 4ac whole divided by 2a. So we have two roots in this equation. We take one root as alpha and the other root as beta. So let us take alpha as one root minus b plus under root of b square minus 4ac whole divided by 2a, and the other root we will suppose it as beta. So minus b minus under root of b square minus 4ac whole divided by 2a. So we have already seen in the previous video that the roots of the quadratic equation ax square plus bx plus c equals to 0 are minus b plus or minus under root b square minus 4ac whole divided by 2a. So there are two roots in this. One root we are taking as alpha and the other root we are supposing as beta. So first we will see what is the sum of the roots, alpha plus beta. Okay, so let us see what is alpha plus beta then. So alpha is minus b plus under root of b square minus 4ac by 2a, plus beta is minus b minus under root of b square minus 4ac whole divided by 2a. So we have two terms here, alpha and beta, both we are adding. The denominator is common. So the common, whenever the denominator is common, we can take the LCM as the same denominator here. So 2a will be the LCM of these denominators. We can straight away add the numerator. So minus b plus root b square minus 4ac and minus b minus root b square minus 4ac. Both we are adding, the numerators we are adding. So plus root term and minus root term we can eliminate, we can cancel. Minus b is 2 times. So we have minus b 2 times, that is minus 2b by 2a. So we can cancel this 2 and 2. So minus b by a. So alpha plus beta is equals to minus b by a, which gives the condition that sum of the roots is equals to minus b by a. Same way we can prove the product of the roots condition. So let us now multiply alpha into beta. What is alpha? Alpha is minus b plus under root of b square minus 4ac by 2a into beta. Beta is minus b minus under root of b square minus 4ac whole divided by 2a. So this time we are multiplying both the roots alpha and beta. So the numerator is in the form of a plus b into a minus b. So we can consider the formula a plus b into a minus b, which is nothing but a square minus b square. So let us use this condition, this form, this identity. So minus b plus root b square minus 4ac and minus b minus root b square minus 4ac. The numerator is in the form of a plus b into a minus b. So we can write a square minus b square. Whereas the denominators, you need to multiply both these terms, 2a and 2a. So 2 into 2 is 4, a into a is a square. So we get 4a square. So numerator we are using a plus b into a minus b, a square minus b square. Denominator we are multiplying 2a and 2a, we get 4a square. So minus whole square, when you square the negative term it becomes positive. So we have b square minus, here we can cancel the root and the square. This is root b square minus 4ac whole square. So we can, when you square the root and square both gets cancelled. Don't forget to use the bracket because we have minus sign outside and we are cancelling root and square. So this is b square minus, now both the bracket terms should be multiplied with minus sign. So we have minus b square, minus into minus is plus 4ac whole divided by 4a square. So plus b square minus b square we can eliminate. We have 4ac by 4a square. So we can cancel 4 and 4 and 1a from numerator, 1a from denominator. So we have c by a remaining. So we have got alpha into beta value as c by a. That means we have got the product of the roots condition. So product of the roots is equals to c by a. So this is how we get these two conditions, these two forms. Sum of the roots of a quadratic equation is equals to minus b by a, and product of the roots condition is equals to c by a. So let us now see how to solve the problems using the sum of the roots and product of the roots condition. Here we have a problem. If alpha comma beta are the roots of the equation ax square plus bx plus c equals to 0, we have to find the value of certain terms. We are given here different terms. We are asked to find the values of these terms. We have to find, in fact, in terms of a comma b comma c. So this should be actually like this: the value of these terms in terms of a comma b comma c, we can say, to get a more clear idea. So remember, whenever we have roots in the equation, we always have to use sum of the roots and product of the roots condition. So we are given alpha comma beta are the roots of, we are given alpha comma beta are the roots of ax square plus bx plus c equals to 0, quadratic equation in standard form, which implies that we can write sum of the roots and product of the roots condition. Sum of the roots alpha plus beta is equals to minus b by a, and product of the roots alpha into beta is equals to c by a. So this term, this thing should be common for all the bits whichever you are finding. There are 4 different bits given here, 4 different terms whose value we have to find. For every term you need to write this separately. You might not be given all the 4 as one problem. This is the 2 marks problem, so you might be given one bit for one problem with only one case. So for every case you need to separately write that alpha comma beta are the roots of the equation. So sum of the roots is minus b by a and product of the roots is c by a. So we just have to keep in our mind that whenever we have the roots and the equation both available, we always can solve the problem using sum of the roots and product of the roots conditions. Okay, so let us see what is the first bit. We are asked to find the value of 1 by alpha plus 1 by beta. So straight away We will take out the LCM, product of denominators, alpha into beta. Cross multiply in the numerator. Beta into 1 is beta, plus alpha into 1 is alpha. We have the value of alpha plus beta as minus b by a, and alpha into beta as c by a. So by a and by a we can eliminate, remaining is minus b by c. So we have got the value of 1 by alpha plus 1 by beta as minus b by c. Similarly, we can find the value of the other term. The second one is 1 by alpha square plus 1 by beta square. So once again we'll take out the LCM first. Alpha square into beta square, product of denominators, because there are two different terms in the denominator. We multiply them. Cross multiply in the numerator. Beta square will go with 1. Beta square into 1, and alpha square into 1 here will be alpha square. So we have alpha square plus beta square in the numerator, but we don't have the value of alpha square plus beta square. We have the value of alpha plus beta here. So what we can do here is we can use the formula. We have a plus b whole square. A plus b whole square is a square plus 2ab plus b square. So we can write a plus b whole square minus 2ab. We can bring this 2ab on the other side, becomes minus. So we will be left out with a square plus b square. So we can make use of this formula or this identity here. This is the numerator, alpha square plus beta square. The numerator is in the form of alpha square plus beta square is in the form of a square plus b square. So a square plus b square we can replace and write a plus b whole square minus 2ab. Denominator we can write alpha, beta, commonly we can write the square out. Okay, so the numerator is alpha square plus beta square. Using this form a square plus b square, we can write a plus b whole square minus 2ab. Denominator we are writing the square commonly outside. Now we can substitute the values of each and every term here. Alpha plus beta we know is minus b by a, whole square will be as it is. 2 into alpha beta is c by a, whole divided by alpha beta whole square, that is c by a whole square. So minus, when you square, will become plus. So each term you have to square, numerator as well as denominator. Minus 2c by a whole divided by c square by a square. First of all, we'll take out the LCM of the numerator. We have a square here and a here. So a square is the bigger term. So a square will be the LCM of the denominator. A square into 1 is a square. 1 into numerator, that is 1 into b square. A into a will be a square. A into a will be a square. That a we need to multiply with numerator. A into 2c will be 2ac, whole divided by denominator is c square by a square. So by a square we can cancel. We have b square minus 2ac whole divided by c square. So this is the value of your second term. 1 by alpha square plus 1 by beta square is b square minus 2ac by c square. Now the third term is to find the value of alpha cube plus beta cube. We have the formula a plus b whole cube is equals to a cube plus b cube plus 3ab into a plus b. If we transfer this 3ab, if we go back, if 3ab, if we transfer this on the other side, we have a plus b whole cube minus 3ab into a plus b is equals to a cube plus b cube. So we can use the same identity here. A cube plus b cube we can write as a plus b whole cube minus 3ab into a plus b. Okay, so alpha cube plus beta cube is in the form of a cube plus b cube. From a plus b whole cube we can derive the value for a cube plus b cube as a plus b whole cube minus 3ab into a plus b. Using the same identity, we are writing alpha cube plus beta cube as alpha plus beta whole cube minus 3 alpha beta into alpha plus beta. Now alpha plus beta is sum of the roots. We know sum of the roots value is minus b by a, and alpha into beta is product of the roots. Alpha plus beta is again sum of the roots value. So both sum of the roots and product of the roots values we are using here. Minus 3 times will remain minus b power 3 a power 3. Both numerator and denominator are applied power 3 separately. Now this we need to multiply this term. Minus into this minus will become plus 3 into bc by a into a will be a square. Minus and minus we are multiplying. 3 we are writing as it is. C and b we multiply, we get bc. Denominator is a into a, we multiply, we get a square. Now here we have a cube, here we have a square. So obviously a cube is greater than a square, so a cube will be the LCM. Now a cube into 1 is a cube. So we have 1 in the middle. A cube into 1 is a cube. 1 into numerator, that is 1 into minus b power 3. Now a square into a is a cube. A square, when you multiply with a, you will get a cube. So a you have to multiply in the numerator. 3abc. You can also say like this, we have a cube here, LCM is a cube, so everything is there. Simply we write on the numerator. Out of a cube we have a square here. 1a is missing, that 1a we need to write in the numerator. Okay, it's just the way how you understand and how you are able to produce it. So what we have now is 3abc minus b cube by a power 3 is the value of alpha cube plus beta cube. Same way the last term is 1 by alpha cube plus 1 by beta cube. So simply we will take out the LCM first. Two different terms, alpha power 3 into beta power 3, both we will multiply. So product of denominators is the LCM. We will cross multiply in the numerator. Beta cube will go on the left and alpha cube will come on the right. So cross multiply beta cube into 1 plus alpha cube into 1. Now again the numerator is in the form of alpha cube plus beta cube. Just now we have derived the value. Everything you have to write as it is and solve. So we can write this alpha cube plus beta cube also, because both are positive terms. Any term can be written first. Denominator we can write alpha beta power 3 commonly we can write out. Now for numerator you have to do everything what you have done here for your third bit. So I will directly write on the value 3abc minus b cube, but denominator is alpha beta, product of the roots is c by a, that will be whole power 3. Okay, just a minute, we have to write whole divided by a cube. This is the alpha cube plus beta cube value, and alpha beta is c by a whole cube. So you might not be given both of them together in the examination. So for alpha cube plus beta cube, whatever you have done here, you have to do the same thing for numerator. Okay, so we have 3abc minus b cube by a cube. Denominator you can apply power 3 separately for both c and a, so we have c cube by a cube. So by a cube and by a cube we can cancel, we can eliminate. We have 3abc minus b cube by c cube as the value of 1 by alpha cube plus 1 by beta cube. So this is how you have to solve. Remember, whenever the roots and the equation both are available, both are given, we solve the problem making use of sum of the roots and product of the roots conditions. Quadratic equation, ax square plus bx plus c equals to 0. Here c is not equals to 0. Find the value of ax1 plus b whole power minus 2 plus ax2 plus b whole power minus 2 in terms of a comma b comma c. So we are given a quadratic equation. We are also given the roots as x1 comma x2. We are asked to find the value of this term. So let us use what is given to us first of all. So we can write on given x1 comma x2 are the roots of the quadratic equation is given in standard form ax square plus bx plus c equals to 0. We are given these x1 comma x2 are the roots of this quadratic equation ax square plus bx plus c equals to 0. Remember, we are given c is not equals to 0. So whenever we have roots in the equation, we always can depend on sum of the roots. X1 plus x2 is equals to minus b by a, and product of the roots x1 into x2 is equals to c by a. So x1 comma x2 are the roots of the equation. We have roots as well as the equation. We always can depend on sum of the roots and product of the roots condition in order to solve and find the value of this term. This is one case. Also, we can use it one more concept here, like also x1 comma x2 are the roots of ax square plus bx plus c equals to 0. This implies, since these two are the roots of this equation, we can substitute both these values in place of x. So we can substitute x1 in place of x and write ax1 square plus bx1 plus c equals to 0. So we get ax1 square plus bx1 is equals to minus c. We can take out x1 common. We have ax1 plus b is equals to minus c. So ax1 plus b can be written as minus c by x1. Similarly, we are given that x2 is also a root of the equation. So we can substitute x2 in place of x, because x2 is also a root of this equation. So again we can write ax2 square plus bx2 is equals to minus c. We can take out x2 common. We have ax2 plus b is equals to minus c, so that ax2 plus b value can be written as minus c by x2. So we have got two conditions. One is the sum of the roots and product of the roots condition. And also, because the x1 is the root of this equation, we can substitute x1 in place of x. We get the value of ax1 plus b. And x2 is the root of the equation. We get ax2 plus b value also minus c by x2. Now, what is that we have to find? We have to find the value of this term ax1 plus b whole power minus 2 plus ax2 plus b whole power minus 2. In order to make the power positive, we can write this as 1 by ax1 plus b whole square plus 1 by ax2 plus b whole square. So we have the value of ax1 plus b here. Let us say this as equation 3, this as equation 4. Sum of the roots we will take as equation 1, product of the roots value we take as equation 2. So ax1 plus b from equation 3 we can write this as 1 by minus c by x1 whole square. But 1 by ax2 plus b from equation 4 we can write minus c by x2 whole square. So when we square and simplify, this will become reciprocal of the term. So x1 square by c square plus x2 square by c square. So the denominator is same. Remember, we are using equation 3 and equation 4 here in order to write the value of ax1 plus b and ax2 plus b. So when you reverse this, this will become x1 by c whole square. You can square separately both the terms. Same here, this will become x2 by c whole square, that is x2 square by c square. So denominator is same. We can write c square as the common denominator, or the LCM. We can add the numerator values. Now the numerator is in the form of x1 square plus x2 square. So we can use the condition, the formula, the identity. A square plus b square we can write as a plus b whole square minus 2ab. So let us make use of this form here. Assuming that this is in the form of a square plus b square, we can write a plus b whole square minus 2ab whole divided by c square. So we can substitute the value of x1 plus x2 as minus b by a whole square from equation 1, and we have x1 x2 value as c by a from equation 2 whole divided by, we can write this as c square. So when you square the numerator, this minus b by a whole square separately, minus will become positive, b square by a square minus 2c by a whole divided by c square. So first we will take the LCM of the numerator term. Numerator is LCM of numerator a square, and a, the LCM will be a square. So we have a square here, we can write down the numerator as it is. We have one a less here, a square is here, the LCM, but we have a here. So one a is missing, that a we should multiply in the numerator. And c square we can write in the reverse form as 1 by c square, because the c square is nothing but c square by 1. When it comes up, it becomes 1 by c square. So the value will be b square minus 2ac by a square into c square. The final value of the given term ax1 plus b whole power minus 2 plus ax2 plus b whole power minus 2. Now let us see how to write the quadratic equation when the roots are given. So a quadratic equation whose roots are given as alpha comma beta can be written as x minus alpha into x minus beta is equals to 0. Generally we know the concept that how many roots we have, that many factors we can write and equate to 0 to get the required equation. So we have two roots here, we can write two factors, x minus first root into x minus second root, and equate to 0. We get the required equation. So this, if we simplify, we get this form, that is x square minus alpha plus beta into x plus alpha beta equals to 0. So we have the roots as alpha and beta. So we can write the equation as x minus alpha into x minus beta equals to 0. If you multiply these two brackets, x into x, x square, x into minus beta, minus alpha into x, minus alpha into minus beta is equals to 0. Now from these two middle terms, we can take out minus x common. We have beta plus alpha here. You can write beta plus alpha or alpha plus beta. So x square minus alpha plus beta into x plus alpha beta equals to 0. You can also write this form as x square minus sum of the roots. We know alpha plus beta are the roots. When we are adding them, it's called as sum of the roots. So x square minus sum of the roots into x plus alpha into beta is the product. So product of the roots is equals to 0. So this is the way to remember the equation when the roots are given. You can write the quadratic equation as x square minus sum of the roots into x plus product of the roots equals to 0. X square minus sum of the roots into x plus product of the roots equals to 0 is the quadratic equation we can write when the roots are given as alpha comma beta. Okay. So let us solve a couple of problems on how to form the quadratic equations when the roots are given. The first case here is p minus q by p plus q and minus of p plus q by p minus q. So we are given two roots here. Let us take the roots as alpha and beta. Let alpha is equals to p minus q by p plus q and beta be the other root, minus of p plus q by p minus q. Remember, this minus is given in the middle. That means minus is applicable to both p and q. This is not minus p plus q. This is minus of p plus q. Means minus p minus q. Both p and q should be multiplied with minus sign. Okay. So first we will find sum of the roots. We know alpha and beta. So we can write sum of the roots. Alpha plus beta as p minus q by p plus q. This is alpha plus beta, p plus q by p minus q. So we can write this as p minus q by p plus q. This plus into minus will be minus, p plus q by p minus q. Let us add both these. Let us simplify it. P plus q into p minus q. The denominators are different. We need to multiply the denominators, cross multiply in the numerator. This p minus q will get multiplied with p minus q. So this becomes p minus q whole square. Minus in the middle will be as it is. This p plus q will be cross multiplied with this p plus q here. So this becomes p plus q whole square. So p minus q whole square we can expand using a minus b whole square formula. A square minus 2ab plus b square. Use the brackets as it is. P plus q whole square we can expand using a plus b whole square formula. So this is a square plus 2ab plus b square. Whole divided by the denominator is in the form of a plus b into a minus b. We can write a square minus b square. So let us simplify the numerator. We will open the bracket p square minus 2pq plus q square. The second bracket, all the terms should be multiplied with minus because we have minus outside. So this is minus p square. Minus into plus 2pq is minus 2pq. Minus into plus q square will be minus q square. All divided by p square minus q square. So p square plus and minus q square plus and minus you can cancel. You have 2pq, 2pq 2 times. Both are having same sign. So this is minus 4pq by p square minus q square. This is the sum of the roots value alpha plus beta. Now let us find what is the product of the roots value alpha into beta. So this is p minus q by p plus q into minus of p plus q by p minus q. This is into, so you can straight away cancel this p plus q and p minus q. You are remaining with minus 1. So the value of alpha beta is minus 1. Therefore, we can write the quadratic equation. The required quadratic equation is x square minus sum of the roots into x plus product of the roots equals to 0. That is x square minus, we have the value of alpha plus beta as minus 4pq by p square minus q square into x, and alpha beta value is equals to minus 1. Either you can leave it here or you can also take the LCM and write this equation as p square minus q square into x square. That means this p square minus q square is multiplying here as well as it is multiplying with minus 1. Minus of minus will become plus 4pqx, then minus of 1 into p square minus q square is equals to 0 is the required equation. Same way we can solve the second bit as well. The second bit given to us, the roots are given as 7 plus or minus 2 root 5. So let us take alpha as 1 root, 7 plus 2 root 5, and beta as the other root, 7 minus 2 root 5. Then first we will find what is the sum of the roots value, alpha plus beta. So 7 plus 2 root 5 plus 7 minus 2 root 5. Here plus 2 root 5 minus 2 root 5 we can cancel. We get 7 plus 7 as 14. Same way let us see the product. 7 plus 2 root 5 into 7 minus 2 root 5. So a plus b into a minus b form. Here we can write this as a square minus b square. So 7 square is 49. 2 square will be 4 and root 5 square will be 5. 4 into 5 will be 20. So we get 49 minus 20 as 29. Therefore, the quadratic equation can be written as, the required quadratic equation can be written as x square minus sum of the roots into x plus product of the roots equals to 0. So you can make use of this formula. That is, we will substitute the value of sum and product here. X square minus alpha plus beta value is 14. X plus alpha beta is 29 is equals to 0. So this is how you can find the equation as well as the roots. Okay, when the roots are given, you can find the required quadratic equation. So let's see couple of more bits where we are given roots. They are asked to form the quadratic equation. The third case here, we are given couple of roots here. Let us take the roots as alpha is equals to m by n and beta equals to minus n by m. Then first we will find what is the sum of the roots value, alpha plus beta, m by n plus minus n by m. So sum of the roots, this will become m by n, plus into minus will become minus n by m. Denominators are different, so we need to multiply. N into m is mn. Cross multiply in the numerator, m into m is m square, minus n into n is n square. So this is the sum of the roots value. Same way we can find the product, m by n into minus of n by m. So you can cancel n and n, you can cancel m and m, minus sign will be remaining. That means the value of the product is minus 1. Therefore, the quadratic equation can be written as x square minus sum of the roots into x plus product of the roots equals to 0. That is x square minus of m square minus n square by mn into x plus alpha beta value minus 1 equals to 0. Either you can leave it here, or you can also write by taking the LCM or cross multiplying with mn. So you have mn x square minus of m square minus n square into x minus 1 into mn is minus mn equals to 0. So this is your required quadratic equation. So the next bit, we have two roots given here again, minus 3 plus or minus 5i. We will take one root as alpha, that is minus 3 plus 5i, and the other root beta will be minus 3 minus 5i. So first we will find what is the sum of the roots, alpha plus beta value. So minus 3 plus 5i plus minus 3 minus 5i. We are writing alpha plus beta. So minus 3 plus 5i minus 3 minus 5i. So plus 5i minus 5i we can eliminate. Minus 3 will be minus 6. And product of the roots, minus 3 plus 5i into minus 3 minus 5i. A plus b into a minus b form this is. We can write a plus b into a minus b as a square minus b square. So minus square will be plus, 3 square is 9, minus 5 square is 25, I into square is iota square. Remember the value of iota square is minus 1. We can go through the complex number video in order to learn about iota square. So iota square is minus 1. So 9 minus into minus plus 25 will become 34. Therefore, the required quadratic equation is x square minus sum of the roots into x plus product of the roots equals to 0. That is, you need to substitute the value of alpha plus beta, which is minus 6 into x plus 34 equals to 0, which implies the equation is x square plus 6x plus 34 equals to 0.